Alright everyone, and we are back with a Chevy project today. Some of you who have joined our YouTube channel from TikTok will already know what we're talking about today, but this is the video where I go over a more in-depth look at doing the old school style sequential taillights. These use incandescent bulbs instead of using LEDs, and basically using time delay relays instead of like Arduinos or any kind of like the more technical side of things. So you can just wire these up on your workbench, even if you're uncomfortable with like coding and stuff like that. Plus they have a very satisfying look, very satisfying sound, and they're fully adjustable and pretty safe. Like if one bulb fails, it doesn't knock out the whole circuit. So follow along and I'm going to show you exactly how all this works, the parts we used, etc. And we'll link everything in the description below as well. That way you can click on that and know you're getting the right stuff. I should also mention this design is actually completely universal. So while I'm doing it for my '59 Bel Air, you can do this with any vehicle. Really, if it has 3 or more bulbs, it'll look good. And of course, you can add bulbs like I am as well. So follow along, and it should make sense with how it all works, and then you'll figure out how to adapt it into your vehicle. So ever since I got the Chevy, I knew I wanted to do sequential taillights. I looked at the lenses, I saw the 5 segments, and I just knew it would be perfect for it, and I'm finally getting around to it. But there's a small problem, and that's really that they only make LED sequential taillights for this car that come off the shelf. And I personally don't like the way that LEDs look on classics. Everyone's taste is different, and if that's your thing, that's totally cool. Honestly, it's a lot easier to do it with LEDs, but, for me, that's not my look. So I had the challenge of figuring out, how do I do this with regular incandescent bulbs? And a lot of people chimed in saying, well, just use the Mustang units and things like that. But the challenge with those is that they only sequence 3 bulbs, and my taillight has 5 segments, and I'm doing 5 bulbs. So I had to come up with my own way of doing this, and basically figure out a circuit that worked to where I could do it with 5 bulbs. And I did just that. As you probably figured out, I've already got one side done. I did that on my TikTok because honestly, I have no idea people were even going to care about this project. And when I started sharing it on there, it blew up. And a lot of people were interested in seeing a more in-depth view of how it's done. So without further ado, I'll show you the side that's done so you can see what the sequence looks like, and then we'll come back to how it all works. Good lord, I feel like I'm on the surface of the sun. So to start with, here's what the factory turn signal looks like. Pretty wimpy, and as you can see, just 2 bulbs in there. Now for my upgraded one, the sequential over here. That is much better. You can also see how much significantly brighter this light is. And that animation sequence is handled by this little contraption right here. Pretty cool, right? So, as you saw, not only do we get the cool animation sequence, but also you get a significant improvement in brightness. So even though we're using traditional incandescent bulbs, those are the same ones from the factory, because of the new way that the wiring works, they're getting direct power from the battery instead of through a really long convoluted circuit, so they're much brighter when they light up as well. You probably also noticed that I looked a little bit rough and ready in my trunk there, and that's because this was absolutely a concept and a prototype when I was putting it together. Like I said, I didn't expect it to blow up, and when it did, I was kind of cruising through it and getting things done to keep our audience entertained. So, the finished stuff is yet to be done, but I will be 3D printing and setting up enclosures for them. I'll be setting everything up in a nice, tidy package, but for now, I'm focused on showing you guys how to do this yourselves. So, first things first, the bulbs. I figured for ease of use, I wanted to stick with the same type of bulb that my Chevy used from the factory, as well as the same size bulb socket, so that I basically didn't have to drill or change the existing holes, I just had to add my own. So I did a little research, and I figured out that the Chevy uses 1034 or 1157 bulbs, which are extremely common in the 50s and 60s. Basically, that's your 2-filament bulb, so it does your running lights and your brake lights, and they're all over the place, and they are dirt cheap. Knowing I'd have to be adding additional sockets, I decided I did want to do all new sockets for all 5 bulbs on each side, rather than trying to find a way to tap into the existing one, because the old wiring on the car is not bad, but it's not perfect, and I figured since I'm doing this, I might as well go all new at the time. So I found a brand called OER, and they basically make these little guys. Pre-done bulb sockets that take that style of bulb, and basically they have a pigtail, and it's easy to set up. We'll link those in the description as well. On my car, the holes in the taillight bucket are in the bottom, and they're 1 inch or 1 1/16 inch. However, I did find that actually they're probably closer to 1 inch. So that's something that I would just measure yourself if you have like a caliper or something like that, where you can get in there and actually measure the diameter. It'll make your life a little easier. I did the research, figured it out, bought these, and then discovered I really probably should have gone slightly smaller on the hole. That's a mistake that you guys won't have to make. So I got to work, I sourced the bulbs and I sourced the bulb holders. I would not recommend getting the bulbs from Rock Auto. Even though they're cheap, it took me 3 rounds to get these right because they kept showing up broken and just loose in the box and mixed and matched and all this stuff. So just get them from an auto store. The amount of money you save is not worth the headache from Rock Auto. But anyway, I have 10 bulbs that I got. You may need less if you're doing a smaller sequence. And then basically, I got the 10 holders as well, and they're not too bad. I think these were just a couple bucks each, and the bulbs were like, 30 cents each or something like that. So once I figured out the bulbs, there was the other consideration of how I wanted this all to go together. In the past, especially when I was younger, I would just get in there with wires and solder everything together in place, and it would work, but it would be permanently in the car. If I ever had to service anything, I'd have to get out the snips and cut the thing out. So this time around, I wanted to make this thing removable and basically easy to install almost in segments. So I got these connectors that are basically weatherproof and pretty affordable, and they've allowed me to basically make it to where I can build one section, bring it to the car, install it, and then plug it all together in the car. That way it's got improved serviceability. So for instance, I had an issue with one of the bulbs. I was able to just unplug the bulb housing that you were just looking at and bring it back into my shop to work on it rather than having to sweat out in the trunk of my car and get it done there. And these are those connectors. And same deal, I'm going to link the kit that I got in the description below. I think I paid just over 30 bucks and it came with an absolute ton of them. So these are the 5-pin connectors, but it comes with 1, 2, 3, 4, 5, and 6-pin ones. And I've used almost all of them except for the 6-pin just to really get this thing to where I can break it apart into its component pieces. Then as you can see, basically these run to my bulb holders. And the way I've set it up, I have the male, this one right here, the male plug is on one side of the circuit and the female is on the other. And that way I can't accidentally plug the low filament into the high side or vice versa. As much as I don't think that would hurt it, it just makes sure that it always goes the right way around. And then obviously the opposite plug is on the actual time delay part of the circuit so that it only goes on one way. I have a short video on our TikTok of how to actually install those connectors. It's pretty straightforward. If you guys are interested, you can check it out over there. If you're super interested and you really need to see it on YouTube, let me know. I will make a video over here. Just drop it in the comments. But for now, I'm going to skip that part just to save a little time. You don't need to watch me assembling connectors. Unless you really, really want to. This is what the kit looks like, and as you can see, it comes with a lot of stuff. So I'm definitely going to have some left over, which is good because we always have multiple car projects going on, and this will let us use it on future vehicles. So after figuring out the bulbs, there were 2 main things I had to deal with, which is basically how to deliver power to the bulbs properly, because obviously 5 bulbs is going to draw way more than the factory 2 bulbs would, and I really didn't want to cook the factory wiring, which is a little wimpy to be honest. And then on top of that, not just delivering the power, but then creating the time delay sequence and also triggering the time delay sequence. How would I get it to repeat when the turn signal was going on? So my goal was to try and be able to work with the factory flasher unit, do as little adjustments as possible, and really try and get a sequence that worked within the standard flash that the vehicle already had. And I did, as you saw, succeed on that. I never actually had to replace the flasher unit. I was able to adjust the time delay sequence to where it runs within one sequence of the regular flasher. So the nice thing about doing it that way is the trigger wire is literally just one of the original bulb socket wires. So when I cut that bulb socket off, that became my new input wire that sent the signal to start the whole time delay circuit. And I'll show you how that all works on paper so you can kind of see what I'm talking about. I decided to come inside for this part because it is super hot out there. So here is the circuit that I created, and feel free to pause the video now, that way you can kind of really see how it works. But I'm going to walk you through each of the different sections here, and of course if any of you guys actually need to see this diagram or anything, I might be able to either send you a link or share it somehow as well. But for now, we're going to walk you through this. So as you can see, we've got our bulbs here. We've got 5 on this side, 5 on this side. And you can see how I've got this green line going between them here, representing basically that these are grounded by the bucket itself. If yours is set up differently, you may need to actually have the socket grounded, but on mine, the moment the socket is clipped into the bucket, it is grounded. So that's easy, that makes my life great. So really all I'm dealing with is the low filament and the high filament, i.e. low for the running lights and high for the brake and turn signal. So essentially, I have to kind of handle these two different ways, and you'll see how I've done that here, basically in using a relay for the running lights, and then two separate relays for the brake and turn signals. So I guess we'll get started on probably the running light. So as you can see up here, where I have factory running light input. So on my car, there was a black and a pink wire for each bulb in the back. The black wire did the low level or the running lights, and the pink wire did the high level or basically the turn signal and brake lights. So when you turn the lights on the car, it sends power down this wire. So essentially, I have that, instead of powering the bulb itself, I have that clicking a relay here. And basically you can see this just goes off to ground. So when power is supplied to this wire, it closes this relay, allowing current to flow through, and I have a constant coming from the battery waiting at this relay. As soon as this relay allows power through, oh, and by the way, I moved the fuse to before the relay. Some really smart Sparkies on TikTok let me know it's smarter to do it that way. So as much as I show my fuse after here, I ran mine before, and you should probably do the same. So basically, boom, power comes through the fuse, through the relay, and literally, I'm able to power all 10 bulbs off of this one circuit, because this is the low filament, so it does not draw as much amperage. And it doesn't really need to independently control each side. It is literally just when you turn your taillights on, it powers all of them. So that circuit is incredibly easy. Pull the lights, and it clicks this relay, sends power to all 10 bulbs on the low side filament. But for the turn signals and brake lights is where it gets a little bit more interesting, because those have to be handled individually. Basically, when I put the turn signal on the left side, only the left side needs to do its job. Same with the right side, but when I hit the brakes, both sides need to light up. And I had an easy solution for that. So as I mentioned, all of the factory bulbs had a pink and a black connection. The pink being for the high side, right, for the high filament for your turn signal and brakes. So I basically took one pink wire from each side. Again, I snipped the bulb sockets off. I sealed off one of the pairs that I wasn't using, one black and one pink, and I kept one pair that I was using. And basically I took the pink wire and essentially connected that as my trigger wire for my turn signal. And the nice thing is the logic is all handled up front by the factory wiring of the car. So essentially, when I put the turn signal on, it's already sending pulses of 12 volt down this wire. If I click the other turn signal, it's sending pulses of 12 volt down this wire. And then basically if I hit the brakes, it just sends a constant 12 volt down both wires. So that handles the logic without me having to do any fancy wiring. So basically, let's say I put the turn signal on. It's going to send power down here, and same deal. I have it going to a relay, just like I did with the taillights, because again, we're drawing a lot more amps, and that let me basically pull direct from the battery with a higher gauge of wire, which you see here. And then essentially, when this is triggered, it allows power through here. Same deal, I moved the fuse to the other side of the relay, so it's before the relay, not after. And it comes into our beautiful time delay circuit. Ignore that pink line there, that was not supposed to be there, but I didn't feel like printing another one of these. So the time delay circuit basically is its own thing, and I'm going to get into that now. So we already know that basically the input to the time delay circuit is going to be handled exactly how the factory input would be. If you put the blinker on, it'll flash just like a normal blinker, so it's sending pulses of 12 volt in time with the standard flasher relay up front. You hit the brakes, it's going to send constant down both of those pink wires. So that makes our life very easy. We simply have to make a time delay circuit that runs the sequence that fits within the flasher's time delay. And basically, these adjustable time delay relays make that very, very easy. So one small hurdle I did have to overcome is that being a standard factory flasher relay, there's a limited amount of amperage that it'll work within. So you do need it to draw a certain amount for it to actually flash. Some people may have noticed that if you put LED bulbs in with an old style flasher, sometimes you can run into what's called hyper flash, where it flashes too fast, or it won't flash at all. So what I've done to combat this is basically make sure that the very first bulb is powered directly from that circuit. It's not delayed by a relay. So as we mentioned, I put my turn signal on, a pulse of 12 volt comes through, clicks this relay, allowing power to come through here, and basically comes into this circuit. Now, in the instant that that pulse starts, it supplies power to the high filament of the very first bulb. This is the furthest one inboard towards the middle of the vehicle, right? So instantly this bulb lights up. Also, at the same time, it supplies power to the trigger side of our time delay relay. And I should explain basically that this time delay relay has two sides to its circuit. It has the trigger side here, which is where basically it receives its input, knowing when to start the delay sequence and when to stop it. And then it has its output side here. And basically, the moment that it receives signal here is when it starts the delay, right? So it goes, okay, from the moment I receive 12 volt, I'm going to wait your calibrated amount of time before releasing 12 volt. So essentially, and then I should also mention that on this version of the circuit, I have it also powering the common pole of the output. So this is where it actually is drawing power from. And basically there's two ways to do that. You can either share it off of this wire so that, again, the moment it receives power, it's supplying power ready to release on all of these, or you can just have a standalone thing where, basically it's its own piece. I simplified the wiring by doing it this way. It was just less long leads from the battery. So this thing receives power at the same time that the first bulb receives power. As you can see, I presumed for roughly a 1 second sequence here. And notice how we only have 4 delay chips because there's only 4 bulbs that need to actually be sequenced. The first one inherently should be on the moment it receives power. So 0.2 of a second goes by. And at that point, it's going to release power out of this pole right here. Now, it's going to release power to this bulb, lighting that bulb, but also release power into this blue here, which, surprise, surprise, hits the trigger of the next relay. And that is now sequencing its 0.2 seconds. Same deal, waits 0.2 seconds, releases power to the third bulb, comes through here, also supplying power from that same pole to the other relay, and so on and so forth. And on this last one, obviously, because there's not another relay in circuit, when it triggers, it basically just releases power to that. Now, if we've timed everything correctly, the moment that sequence finishes, the flasher relay up front has also finished its sequence and shuts off that 12 volt. As soon as these stop receiving power, they also click close, just like a normal relay, right? So power gone, boom, or I should say, sorry, the relay opens, stopping it from sending power to any bulbs, which means the whole tail light turns off. My original design before that actually had them all receiving power in parallel rather than in series like that. My thought was that by doing it in parallel, it would be better for the load, and it would also be just a little easier and less wire. And a couple people warned me. They said, that's not going to work the way you think it will. You're going to have a lot of issues with those time relays. And they didn't really explain why, but they were right. I first set it up in parallel, and I could not for the life of me get it to sequence properly. It would do like the first 2, maybe 3 bulbs, and then the last 2 or 3 bulbs would all just trigger at the same time. And I never really understood why, but I tried it 5 different ways, and it just would not work. The moment I put them in series like this, it's just a guaranteed way for it to work, because the next chip in sequence cannot start its circuit until the previous one has released power to it. It's just a no-brainer method, and lo and behold, they were right. That's why you sometimes got to listen to smart people on the internet. And to make this easier for you, I'm going to show you what they look like in real life. And by the way, look how good of a job I did rendering those. Pretty good, right? So this is a partially complete circuit that I'm going to be using on the passenger side of the car. And basically, I'm going to walk you through what the different connections are on one of these. So even if you're not using it for this exact project, you'll at least have an understanding of how this works. So we're going to start with the trigger side that I was telling you about. As you can see, you have VCC here by my thumb, and you have GND here by my pinky. So GND, that's obvious, that is just a ground. That basically needs to be connected to a good solid ground. VCC is that trigger 12 volt we talked about. So basically, when power is supplied here, that's what's going to start the time delay circuit. So that is going to tell it start now, and when power is removed from there, it's going to tell it stop now. So next up, we have the other side of the circuit here. So we basically have our COM, which is common, and it's a little tricky if you do house wiring because it's not what it means in house wiring. That basically means that's where the 12 volt power constant is sitting. That's where you need your power just chilling there, ready to be released when this relay does click, i.e. once the time delay finishes and this goes boom and releases power, that's where it's drawing the power from, this middle pole right here. You then have NO and NC. So NO stands for normally open, and NC stands for normally closed. And that basically means that this relay can do two different things. It can either have something that is constantly powered until the time delay kicks on. So basically, when the time delay kicks on, it actually cuts power. And to do that, you would use NC, because that means that the relay is normally closed, supplying power until it triggers. Or you could use normally open, which is what we're using for this circuit. Normally open means that this is open and basically not sending power through to this pole until the time delay triggers. It clicks, making that connection for the normally open side of the circuit. That side is now closed, and it allows power to flow through this pole right here. And again, as you can see on my diagram, that is the pole that we're using as our output right here. So, pretty straightforward once you get to know it. But now, how to make the actual adjustment of the time delay itself. So right here, you see this little brass, little flat blade screw right there. That is literally it. That is how you adjust the time delay. So a teeny tiny little flat blade screwdriver, and basically you would turn it counterclockwise to shorten the delay, or clockwise to lengthen the delay. And this will go anywhere from 0 to 10 seconds. Now the nice thing is, it is actually a lot of turns to get a noticeable adjustment out of this. So it's not one of these like hair trigger things where you turn it 1/32 of a turn and it's way overshot. Several turns will make a very small adjustment. So we're working with the very bottom end of this spectrum. Again, we're basically cranking this all the way back to where there's no delay, and then just starting to go clockwise from there and lengthening that delay. And then once you've figured it out, essentially, the only annoying part really is that you're going to be timing these to try and do all the same amount of delay, and you just got to do that manually. There's no magic to it. As you can see, these are all in different positions. It's not like you can really just eyeball it. So you literally just got to watch the sequence and make sure it has a nice flow to it the way you want, and you'll be able to tell if one bulb is slightly out, and you can just tweak it. So the absolute best part about those relays is they are cheap. I got 10 of them for like $22, I think, so just over $2 a piece. They sell them in 5-packs. I will link that in the description below. They are super readily available. And like I said, I got 10 of them even though I only needed 8, because the reality is that's how they're sold. I didn't mind spending $4 extra to have a couple on the shelf. Because one consideration is, this is a traditional mechanical relay. You heard the clicking earlier in the video as these actuated. They will eventually wear out after many, many, many cycles. So, if you wanted something that would last forever, you would normally want to go solid state. The reality is most cars that these are being put in, you're not going to be driving 24/7. And even if you are, these are going to last a very, very long time. And even if you do wear one out, it's so cheap to replace it. It's not worth trying to figure out an expensive solid state relay for this application. Plus, if I'm being 100% real, that clicking sound is awesome. 99% of the people that have seen that on TikTok have absolutely loved it. I personally absolutely love it. It fits the old school vibe of the car. And a couple people have been like, "Ah, man, put silent relays in there. That's super annoying." Nah, I love that it makes its own little, really satisfying sound when the taillight's sequencing. Plus, my car's so freaking loud I can't even hear it when it's running anyway. So a quick review on this circuit, just based off of the physical model that we have here. So essentially, these being our trigger side here, this is going to be our relay number 1, but technically this is actually for bulb number 2. So I'm actually going to call this relay number 2, 3, 4, and 5, because that relates to the bulb that they power. So bulb number 1 receives power right as the flasher relay turns on. Move that so we don't get confused. So bulb 1 lights up and also supplies power to this. This waits 0.2 of a second and sends power through this little squiggly guy here, not only to the bulb, but to this, triggering this guy. This waits 0.2 of a second, and then basically closes the circuit, allowing power to go to the next bulb, and also through here, setting this guy up. This waits 0.2 of a second, and it releases power out here to the bulb, and also to the final time delay here. Boom, waits 0.2 of a second, and that releases power just to the bulb, and that's it. That creates that smooth sequence. So the nice thing is as well, if you want a slower sequence, you can always dial these back and actually slow down the delay so that the bulbs go slower, but just keep in mind, You'll then have to start messing with your factory flasher relay and find a way to slow down the overall flash of the circuit. Now, I did an experiment with that. I basically found an adjustable flasher relay. It's designed for motorcycles, but it has a convenient little potentiometer on it, just like these guys do. And it was quoted to do 50 to 200 flashes per second. And my thought was, well, 50 flashes, or sorry, per minute, I should say, 50 flashes per minute is less than 1 flash per second, so it could be slightly slower than my existing circuit. So I purchased that, and after a little bit of fiddling around, realizing that the terminals were backwards on it compared to my car, I got it working, and it actually, even on the slowest setting, it flashed faster than the one that I already have in my car. So it was a bit of a dead end. However, I have had people on TikTok telling me that basically using a resistor, I can slow down the flash of the factory flasher. I might fiddle with that in the future. There's part of me that kind of, wants to make it adjustable if I'm going to do that, rather than just slow it down to one fixed point. I'd like to make it to where I can dial that down up front and then dial down the ones in the rear as well, so it's fully adjustable. That way, you're doing it right. That way you have infinite adjustability in the future. So as a quick review, what you're going to need. You're going to need a time delay relay for each delayed bulb you're going to use, right? So your first bulb in the sequence, you really don't need a time delay for, but your subsequent bulbs do. So let's say you're doing 3 bulbs on each side. You really only need 4 time delay chips, right? Because you got 6 bulbs, only 2 bulbs on each side need to be delayed, right? So you're going to need 4 of those time delay chips. If you're doing 5 on each side like me, like a crazy person, then obviously you need 8 of the time delay things, right? Because the first bulb is not delayed. So that helps you figure out how many you need. And like I said, doesn't hurt to buy a couple extras and just have it sitting on the shelf with how cheap they are. I did manage to blow one up the first time I was testing it, but that was also entirely my fault because I was testing it on a 15-volt battery and really horribly rigged up, just like touching wires to things. And yeah, so I cooked one. But ever since it's been in the car running on the 12-volt, it works absolutely perfectly. So the next thing you're going to need is actually regular relays. You're basically going to need just a traditional automotive relay. And I needed 3 of them, and I think you probably will as well, if you're doing it the way I am. So one relay is going to handle your running lights, and basically it'll be triggered when you pull the regular headlight stalk on your vehicle, and basically that relay will open and send power to all of your running lights across the back. That's its own standalone circuit. You then need 2 more relays, one for each side of the car. And basically, it's the same deal. One handles the left side, one handles the right side, and it just has power ready to go for the high filament of each side. So one relay, it receives power, creates the contact, it then sends power through, and basically it's ready and waiting to do what the time delay circuit tells it to do. But again, that is left and right side specific, so you're going to need one for the left, one for the right. One common question I did get is, what do the brake lights do? And, it seems pretty straightforward, but I'm going to, just run you guys through it as well. They sequence, but only once, because basically it sends a constant 12 volt, and the moment you hit the brakes, they sequence once and then stay lit. Because the way these time delay relays work, until they stop receiving power, they remain, in contact, right? They send power the whole time that they're receiving power. So basically, while you're on the brakes, it's sending 12 volt to the back. So the time delay circuit does its job, and it delays that very first run, but then all 5 bulbs stay lit until I take my foot off the brake pedal. And a couple people said, oh, well, you're delaying your brake lights, that's dangerous. But again, the very first bulb in sequence is not delayed. So you still have that very first bulb that is instantaneous with no delay. And that very first bulb with the direct power that these receive with my new wiring is actually brighter than my factory 2 bulbs. So if anything, it's a little bit safer. Plus, an animated sequence like that is going to catch your attention more than a normal, just standard on-off light anyway. But, if you are very, very concerned about it, check the laws in your area to see if that's legal, because obviously, if you're really worried, I know California can be super picky about stuff like this, it might be worth figuring out a way to make it not sequence when you do the brakes, but sequence when you do the turn signals. That circuit I just showed you does not do that. That sequences when you do the turn signal, and it sequences when you do the brake. So that's a consideration, but here in Florida, it's like the Wild West anyway. So, no one cares. Honestly, they're just grinning from ear to ear when they see it light up. And the last consideration of this is basically stability, or kind of, reliability. If something fails, what gets knocked out? Because, essentially you don't want to lose your brake lights, right? So each component of this, I tried to design it in such a way to where if one thing fails, it has the least amount of fallout possible. So, for instance, like I just mentioned, even if my entire time delay circuit failed, even if the whole thing just exploded, I still have one functioning bulb on each side, whether that be for brakes or for turn signals. So no matter what, it has one bulb that's acting just like a normal bulb, and it will never, never lose that one bulb because it's independent from the time delay circuit. It takes its signal before the time delay circuit even does its thing. So the other thing is, because of the way the bulbs are set up, if one bulb fails in the sequence, like if a physical bulb burns out, that has no effect on the remaining bulbs. It doesn't stop it from receiving power, because the nice thing about these relays is they're doing their job independent of the bulbs. So if I lost like the middle bulb in the sequence, it would still animate just the same. There would just be a dead bulb in the middle. So that's pretty cool. And then the last thing, of course, being that the relays themselves, again, if you do lose a time delay relay, you will lose the subsequent relays after that. But again, you always have the ones before it. And again, think back to the beginning of the video with how dull and crappy factory 50s lights are. And using the same bulbs, just newer wiring, look how much brighter my new circuit is. Even if you're running one bulb, you're getting the same amount of lumens pretty much out of that one bulb as I was getting out of two on the factory thing. So my concern for safety really is minimal. I really think, if anything, this is probably more safe than the factory one, just with how much brighter they are and how much more attention getting they are. Two other things to consider are going to be the gauge of wire to use. So because I'm drawing 5 bulbs on the high filament, that's a lot of amp draw compared to the 2 factory bulbs. So basically each side has its own 12 gauge feed wire from the battery. So when they're lit and I'm sitting on the brake light, basically there's 5 bulbs drawing on one 12 gauge, and that is absolutely a thick enough gauge wire to handle that draw. The factory 20 gauge wire, different story. That would not handle 5 full-on incandescent bulbs on their high side filament. So definitely do a little research on the amperage of what you're going to be drawing. You can figure that out, by the way. Usually these bulbs will tell you their wattage, and that's basically, I believe it's volts over amps or amps over volts, but you can look up the equation. And basically I did the equation for the bulb, figured out what the amp draw for each bulb would be, and then obviously multiplied that by 5 because I'm running them 5 at a time. And then I figured out what the amp rating for the different gauges of wire are. So for me, I did 12. I probably could have gotten away with 14. If you're doing 3 bulbs, reality is you could probably get away with 14, maybe even 16, but probably should just do the bigger one to be safe. So again, do be cognizant of the gauge of wire that you're using just to make sure it's rated properly for this circuit. You will need to use a finer gauge of wire inside of the time delay circuit because the terminals on those are quite small. So I believe I've been using 16 gauge wire within that circuit to make sure I can make all those connections. And then for the actual output power to the bulbs and everything, and the main feed in, I'm running the 12 gauge. And then there's the consideration of heat. A lot of TikTokians were really worried that I was going to melt my taillight lenses. And from what I've seen, that's actually an issue with the classic Mustangs. I think specifically like the 64.5 to 66. Because the bulbs sit very close to the taillight lenses, I believe it's on those Mustangs where I've read that you can actually cook the taillight lens because the brighter bulbs generate a significantly higher amount of heat inside that housing. Now, my housings are huge, and if you took a cross-section of my lens, they're actually kind of convex. They stick out. So that creates a lot of space between the bulb and the lens itself. And that combination of the extra space and the convex nature of the lens, basically it doesn't have any issues. I mean, I've sat in standstill traffic with the running lights on and the high side filament. So both filaments lit on all 5 bulbs, just sitting on the brake for multiple minutes on end, and the taillight lens is completely unfazed. I also made sure that I could get replacement lenses for my vehicle. In fact, the ones that are already on it are replacement ones because one of the lenses was broken when I got it. So I think these newer lenses are a little more robust anyway. And even if I did cook these lenses, I made sure that I could get replacements. So if you're doing this on like a rare, collectible, unique vehicle where lenses might be a real challenge, might want to be extra careful on the heat thing. Really just be doubly sure that you're not going to melt them. And the biggest worry is, again, if your bulbs are very close to the lens itself and your housing is quite small. That's where you'd really start to want to be, really considering, again, You could always just do LED if you're not, weird like me. That'll completely solve that problem. Or if you're a stickler like me and you got to do incandescent, finding a way to vent your taillight lens is probably the next best thing, whether that's passively just by putting a hole in the top to allow heat to escape, or actively using like a little 12-volt computer fan that's powered by this circuit. You could always maybe have it actively pull heat out every time that the lights are on. So a couple of different options that I thought about in case I needed it that I didn't end up needing. So hopefully this little science project has helped you guys out. I thought this was a super cool project, and I thought that this solved a problem that a lot of hot rodders might have run into. If you've been considering doing sequential taillights, you've wanted to do them incandescent but can't find a way to do it, this is a universal way to do it. And of course, as we always say in our videos, if you have any questions about how this works, if you need clarification on anything, you're definitely welcome to just shoot a comment. We'll try and get back to you as quickly as possible with how to approach it, and we'll get you through it. I want to see this on more vehicles, and I would love if you guys do this. If you could share it with us, we'd love to share it on our YouTube, or if you're on TikTok, same deal. Share it with us on TikTok. I want to see other people doing this project. But that's all for now, so we'll catch you on the next one.